This is lecture 12 of Data Science 100 and 200. The topic is the simple linear regression model. So let's start with a recap of the last lecture where we looked at modeling. So we looked at the modeling process. It's a three-step process. The first step is to define the model. The second step is to define a loss function. And the third step is to minimize the average loss to fit our model to the data. So let's start with that first step, choosing a model. So we looked at just one model, the constant model, which is y hat equals theta. Theta is a simple scalar value, and it's a parameter, and parameters define the predictions that our model makes. Second step is to choose a loss function, and we looked at two loss functions, squared loss and absolute loss. Squared loss, we take our value and subtract the predicted value and square that. Absolute loss, we take our value minus our predicted value and we take the absolute value of that. Now the loss functions will tell us how good or bad a single prediction was for one observation in our data set. Now if the predicted value y hat is close to the true value, then our loss will be low. Otherwise, if y hat is far from our true value, then the loss function will yield a high result. Now we want a model that best fits the entire data set, not just one observation. And so we want to minimize the average loss across the entire data set. And that'll help us determine the optimal parameters. So we have two different examples. We have the mean squared error function, and we have the mean absolute error function. In the case of the mean squared error function, we're simply taking our squared loss function, applying it to all values in our data set and their predictions, and taking the average of that. And similarly with the mean absolute error function, we're taking our absolute function and applying that across all of the values and the predictions in our data set and taking the average. And by doing that, we'll be able to determine the best optimal parameters to get the best fit for our model. So smaller average loss values will mean a better fit and give us those parameters that we're looking for to minimize the average loss.